right, we want to solve for the variable here, but we have a fraction multiplied by the variable. Now, you could divide by that fraction. We can always get rid of multiplying by dividing, but it's easier in this situation to simply multiply it by its reciprocal. Two numbers are reciprocals. If when multiplied together, they equal 1. So, hey, if we multiply by its reciprocal, it gives us 1 in front of that n, and that's what we want is 1n equals what? So I'm going to multiply this side by its reciprocal. All I do is I take the fraction and boom, flip it. 2 over 3 becomes 3 over 2. Now, if I multiply that side by 3 over 2, I have to multiply this side by 3 over 2. Now, remember, 6 as a fraction is just 6 over 1. No big deal. Everything here crosses out. The 2 and the 2, 1 on top, 1 in the bottom go away. 3 in the bottom, 3 in the top, they go away, cross out. Leaves me with 1n. Over here, you can cross out, or if you want, you can just multiply across the top, which is 18, multiply across the bottom, which is 2, and 18 divided by 2 is 9. Could have done the same thing here. 6, 3 times 2, 6, 2 times 3, 6, 6 divided by 6, single 1n. So n is 9. That means 2/3 times 9 equals 6. Right? Same thing here. We have the variable that we want to find being multiplied by 2/5. There's nobody else to move. Now, if there was some addition in here, I would need to move my numbers over before I try this trick. So I just am trying. I could divide by 2/5, but that gets tricky. You could change it to do 2 divided by 5, which is 0.4, and then divide both sides with the calculator by 0.4. That would work too. But here I'm just going to multiply by the reciprocal of 2/5, which is just the bottom goes to the top and the top number goes to the bottom, 5 over 2. I'll multiply this side by 5 over 2. And I'll remember that 20 is simply 20 over 1. So all I've done is I've multiplied both sides by the same fraction, 5 over 2. That keeps things equal. Notice up top you'd have 10 and the bottom you'd have 10, and 10 divided by 10 is 1. So everybody crossed out. Here I can multiply across the top, get 100, multiply across the bottom. The denominators give me 2, and 100 divided by 2 is 50. The other option that you did have, and you learned it in elementary school, is you look at the top number 20 and the bottom number 2, and you're like, hey, they both have a common factor of 2, so I'll divide them both by 2. And the 2 becomes a 1, and the 20 becomes a 10, and then 10 times 5 is 50. Divided by 1 is 50. Again, many ways to do things. It all depends on your own knowledge of what you have with numbers and multiplication and everything else. Same thing here. I have 3/4 times the n equals the fraction 2/3. I could change both those fractions to decimals. 3 divided by 4 is 0.75, and I could divide both sides by 0.75. But to me, it's easy to come in and say, hey, just multiply by the reciprocal. When I see a fraction out in front of a variable, I just say, hey, if I multiply by the reciprocal, it'll give me a 1. Since I multiplied the left by 4/3, I'm going to multiply this side by 4/3. Everybody, the 4 and 4 will go away, 3 and 3. Or I could have said, hey, that's 12 divided by bottom's 12. That's just a single n. And over here, look how ugly it is. 2 times 4 is 8. 3 times 3 is 9. It's just simply the fraction 8/9. Now, if you have that in a calculator, that will be 0.8 repeating, because the calculator will say 0.88888, which just means it's repeating. To me, 8/9, I'm 8 out of 9 slices of pizza. I ate almost the whole thing, but there was one little skinny slice left. It's about how I do with pizza. I can eat the whole thing. Number 4. This looks a bit different. What do I do? Well, what we learned is what is always true, and it's very interesting. It's called the means extremes property is its technical name. You guys always learn it probably as the cross product is what we call it in America. And what we realize is when two fractions are equal, now this is just a fraction equals a fraction. No other numbers are involved. There's no adding. Fraction equals fraction. For example, 2/4 equals the fraction 4/8. Do we agree? Because both of those are worth a half, right? So they're worth the same. We notice that these multiplied equal those multiplied. And y'all call it sometimes the butterfly effect maybe, or something of that nature. They taught something like that in elementary school. You got to be very careful. This is only true when the fractions are equal. We don't do this when we're adding them or subtracting them or multiplying them. It's only when fractions are equal. That is the biggest mistake that occurs when we're dealing with fractions. When two fractions are equal, we can say these multiplied equal these multiplied. And that's what we're going to do to solve this problem. Now, let's start with this 4. 4 times, now it's that whole top. You can't just go 2 plus x. It's 4 times that entire top. 4 times the 2 plus x equals 3 times the entire top of x minus 2. Now, you see, you're going to have to do the distribution. You're going to have to distribute, okay, use the distributive property. But it makes the problem a lot easier. Look how easy it is now. 4 times 2 is 8. 4 times x is 4x. Distribute the 3 through. I get 3x minus 6. Now, get all variables on one side, all numbers on the other, and I'll be done. So I'll subtract 3x from both sides. Goes away here. I get x on this side. I have the number 8 equals a negative 6. Don't forget, you must look what's in front of the number to determine its value. Now to get x by itself, get rid of that 8. So I'll subtract 8 from both sides. X equals negative 14. You would have never seen that had you sat there and guessed at numbers. Okay? So whenever I see two fractions equal like this, I'm like, hey, I'm going to use that butterfly effect, or what's technically called the means extremes property. Comes from Europe. That's where that one comes from. The name is what I'm talking about. Number 5. Well, I have a fraction equal and a fraction, so let's do the same thing. These multiplied equal these multiplied. I'll do 10 times that entire bottom of x plus 2 equals 8 times the entire bottom of x plus 4. Now I distribute through. 10x plus 20 equals 8x plus 32. Move your smaller variable over is what I like to do, so that's what I'm going to do here. I get 2x plus the number 20 equals, that goes away, 32. And now I move my 20 over, number to be over with the other number so they can hang out and have a good time. 2x, that goes away, equals 12. How do I get rid of multiplying by 2? We divide by 2, and we get our answer of 6 for number 5. One or two more to go. All right, I have 2/3 times that. I got to distribute that 2/3 through. Well, if you do that, you could use the calculator, change that to 0.666666666 forever, times 12 and get your answer, and then 0.66666 times the 18, and then solve the problem. But let's learn how to do this. I mean, we can change things to use the calculator all day, but let's understand things. I'm doing 2/3 times a 12. That's 12 over 1. So you could cross out here the 12 and the 3 and, divide them both by 3s, or you could just multiply across the top, 24. 3 times 1 is 3, and I know that's 8. So I know this, when I distribute that through, that gives me 8x. Now I want to do 2/3 times an 18 over 1. Now again, I could cross out, or I could just multiply across the top. Gives me 36 over 3, which gives me 12. When I said cross out, we could have said, hey, 18 and 3 both can be divided by 3, which would give you a 1. 18 divided by 3 is 6. 2 times 6, 12. Huh. Amazing. Math always works out. So we have, when we distribute the 2/3 through, we get 8x minus 12 equals 6x minus 8. Now let's move our smaller variable over. Now the problem's easy. 2x minus 12 equals negative 8. I now move my number over, the 12 over to both sides. I get 2x is equal to 4. Divide by 2 on both sides. X is 2 is our solution to this problem. All right, one more to go. So I have 9x minus 6, no big deal. I got to distribute the 3/4 through. So let's do 3/4, which is 0.75. I could do that, but let's learn how to multiply fractions. We want to be intelligent and know everything we can. So I'm multiplying here, so you could cross the 8 and the 4 out, make the 8 a 2 and the 4 a 1, but I'm just going to go, hey, multiply across the top, 24. Multiply across the bottom, 4. That gives me 6. So that's going to be 6x minus 3/4 times the 4. That's 12 over 4, which is 3. That didn't take long. So 9x minus 6 is equal to 6x minus 3. Move our 6x over. We get 3x, take away 6 equals negative 3. Again, don't forget to pay attention to what's in front. I now move my 6 over. 3x equals a positive 3. Get rid of multiplying by 3 by dividing by 3. X is 1 in this problem. All right, there's problems 1 through 7.